Hey guys, it's Vince. Today in this video we are continuing with our CNC controllers built in correctly, but today we have a mill and today we have a Masso retrofit, which I know many of you are interested in, but this is really interesting for you guys going to perform it yourselves. I highly recommend you watch this whole video. It's got some pretty amazing things covered and some things I've never seen before, but again, showing you this live really gets you guys all on the same page of the stories I've seen in the trenches, and now you can see for yourself things not to do and what research to perform before thinking you can do this yourself. It's very important, so let's jump right in. Okay guys, you can see here he's got the Masso laid out, a lot of parts. Of course he's going to cover how he's going to do the retrofit. Again, this is the G3 Touch, the newest version of Masso, so we'll continue to let him go.
Drives. That way, if I want to play around with my fourth and fifth axis trunnion table, it'll be ready to go for that. Also, I want to hook up one of these hand wheels because, yeah, it's just kind of annoying to have to click on the computer.
Okay guys, you can see that we see a shield drain integrated in the pendant that he purchased from Masso, and of course with that shield drain we know that they are using the proper cabling, at least in the fact that it's shielded. This cable is unassembled on that end. He will have to install the connector, but more importantly you need to terminate this shield drain correctly for that cable to properly mitigate EMI. And once again, as we go through this, it becomes really apparent that there is some major issues.
There.
Okay guys, I'm on Masso's website here, you can see right here, and I want to show something, and this is interesting because this has nothing to do with the end user. I want to show you what so commonly happens with a lot of vendors. Now, once again, Masso is the manufacturer of the pendant he's using. You can see the MPG pendant right here. It's allocated right over here on their scroll bar. And when we scroll down, we can see that there's a connector present, and that's that 15-pin connector that this unit uses. Look at this connector carefully, and you're going to realize they don't allocate a position for the shield drain that I've shown in that video. So when we look at this, who do we hold accountable? We all should hold accountable the vendor, because if they don't understand the equipment they're selling, let me ask you a question. Should they be selling it? It's interesting. And as we scroll down here, we can see they go over all the connections. Everything is here, but that shield drain wasn't allocated with anything, a tag or any type of positional location on this connector. It would be here somewhere. We see nothing. Okay, and what's really interesting with this vendor is as we scroll down, okay, you can see you've got a whole list of what you can connect, but when we scroll up to our drives and how drives are connected, I want to draw your attention. I'm just going to pick one arbitrarily. We'll go to the Gecko G203V. I'm going to click on it. Now this is a single drive like many others, like what he's using. What's not being shown here? We just see step signal, direction signal. We don't see anything discussed about what type of cabling to use for signal protection, which would be double shielded. We don't see anything about proper grounding of the system, proper grounding of the drives. Let me guess the vendor feels that Gecko or whoever's selling the drives should take ownership of that. Should they? I'd like to hear your comment on that. The other thing I want to point out, as we scroll up, look at this troubleshooting guide section. If we come over here to ground loops, and we have a lot of information here, you can see everything going on here, once again about hookups, lubrication, you name it. As we come up here though, and it says troubleshooting, we'll click on ground loops. While wiring and setting up a machine or any electrical equipment, grounding loops can be formed between different electronic devices, and high current flowing through the grounding loops can cause sensitive electronic equipment to malfunction or fail. Understanding ground loops, and this is interesting, they don't have any information on it. They copy a video from YouTube. Once again, it's interesting, don't you think? Someone manufacturing motion control equipment would copy a YouTube video and post it. This is not their channel. If we scroll down, examples of damage caused by ground loops. The below show burnt components due to the ground loop on the Masso G3 touch unit. Let's look at that again. The below show burnt components due to the ground loop on the Masso G3 touch unit. Preventing ground loops. On any machine setup, multiple ground loops can happen where long cables are connecting equipment. Some examples. Ground wires between controller and motor drives. VGA screen ground wire between control and VGA monitor. Ground wire between external power USB hub. Note, if the USB hub is only powered by the controller's USB port, then a ground loop is not formed. If a long USB cable is used from the controller and the other side of the USB socket body touches another ground, such as the body of the machine. If the controller's ground pin is connected to the frame of the machine, this can happen. I like this. Can happen on the Masso G3 touch controller via the rear mounting plate. The best way to avoid ground loops is to make sure that the entire machine is only grounded at one point only. The same applies to when wiring the machine frame and other electronics. Ground loops can be formed in a lot of different ways and are hard to document, but having this understanding can help plan the wiring of machines and troubleshooting. Now, I'm going to ask you something logically. Do you feel that they covered in detail how to ground your system? Where is it? Because I don't see it. It's kind of interesting here because if we look, you would think this would be a section over here, but I'm just not seeing it. I mean, we see everything once again with tool changers. Let's come up. Maybe I'm missing it. We see the symptoms of ground loop damage, which once again, this is interesting. Inputs stop working. This would normally affect multiple inputs rather than a single input. Look at all of this, guys. Inputs randomly going high or low. USB stops working. Well, why is that? Because we've already discussed it. USB uses 5 volts, and typically that is an unstable voltage for motion control. Sometimes you have great results, sometimes you don't. Once again, refer to Bows's. I'll put that email in here as well, and you can check that out. But this is very interesting. And once again, coming over here, let's see, warnings and cautions maybe? Masso documentation. Installing Masso. And this is really interesting, maybe under wiring and calibration. Once again, we do not see, I see nothing about grounding. I see a lot of information about different drives. Let's try Technic ClearPath, because again, that's a very popular drive. And nothing. So what does this say? What does this say? I think we need to really think about who we hold accountable and who should be looking at this prior to purchasing. Don't assume because someone releases hardware that they're going to do their homework and provide you the knowledge to use it correctly. When I say use it correctly, hook it up correctly. This gentleman is hooking up, like many we've seen in videos in the past, from point A to point B and thinking everything is great. He thinks it's all done. That's it. It moves. The motion I've achieved, so everything is done. Well, what we've proven here is that it's not done. My channel has shown that greatly. Many of you experienced that, unfortunately. And then when we see things like this, where, like I said, I can't believe we're using someone else's YouTube video to define ground loops. And what is this supposed to do for you end users out there who don't understand that in reference to CNC? There's a lot to learn, gentlemen and ladies. So take your time, do your due diligence, and before you spend your money, ask the right questions. And I'd love to hear comments below. I love when I hear how much I'm helping you. That I love. But I want to hear what you think of this, because this is really interesting.
All right, I've got the machine all opened up.
Okay, guys, I think it's pretty obvious here that we have a complete mess. And of course, it's going to go, and I'm going to actually highlight the other side where he has the drives installed. I find it very hard to believe that he just started to remove everything we see here. I think this stuff was a mess before. I think it's a mess now. Whether he left it that way, didn't leave it that way. Wires like this in such a confined space with electronics generating mass amounts of heat, this is a very, very small enclosure, and it doesn't get any better on the other side, so we'll just let him continue.
This Mach 3 controller to prepare for wiring the Masso.
Okay guys, you can see we have a loose bus bar here, and in all fairness, it is actually insulated because he has a cover on it, but we see loose components. Please do not test your system or leave it in a state that you have loose components, because you will potentially have some serious issues. I've stated this in past videos. I see it done a lot. Pay attention to this.
Install a CR2032 battery.
Okay guys, we can see that we do not have any points of grounding here, meaning ground bus, and of course with the entry point coming into the Masso, it does not mean that you're not going to be running motor cables to make conduction to the terminal block, which means you're going to have to terminate the shield drain so it can be properly grounded. That is best practice. If you're not going to ground it in his case where the drives are mounted, and in your case, then you would have to ground it on the opposite end. And in his case, he really has no room in that enclosure to properly do it. It's certainly not being done, and therefore it would have to be done here. Keep that in mind when you're working with this unit. Grounding is a must on all systems.
Now that I have space in my electrical box, I'm going to get these stepper motor drivers ready to install. Off camera, I got them mounted.
Okay guys, you can see here once again with us actually highlighting his case, there are no shield drains terminated. I want you to pay close attention to that, because now we can see the rear of the enclosure as far as the back plate, and there is no termination. The drives are mounted with zero termination of any grounds, and this is a definitive no-no.
Need to install 2 of these aviator plugs so that I can plug in the trunnion table and remove it whenever I need to.
I mark the positions and drill pilot holes, and then come back with a larger drill.
Okay guys, once again we see something I've never seen. Many of you probably haven't either. This gentleman just installed new drives out of his own mouth, and now that all of his wiring is there along with the new drives, he's drilling into the enclosure. One mistake would have drilled that length into any of these cables, once again, is going to basically destroy a lot of what he's done. Not to mention, how do we know metal shavings haven't actually gone inside any of those drives, terminals, heat sinks? We have no idea. This is probably one of the worst things I've seen. I say that loosely because what you're about to see gets even worse.
Shut the holes.
Because I don't have any good way to actually get this connector in sight here, because it's too large.
Guys, you heard it out of his mouth that the DB25 connector will not fit his enclosure, and that's absolutely true. You have 2 options. You purchase a DB25 punch, which will set you back usually about $800, or you can go with the CNC communication breakout cable. Once again, this design I've had for a while. It allows for explicitly this application for you to break out from a DB25 connection on one end, 2 for rules, and all the individual leads on the other, which are numbered. You will also find that you have a ground pin, just like you should on the regular cable, that you will also ground. All you do is match the numbers on the ferrules, and those are your pins on your DB25 connector, and you're all set. And once again, this unit is extreme high quality in the fact it uses a metal DB25 connector, and the cable is double shielded. The cooling fan, guys, once again, guys, he's faced with the dilemma of notching 2 or maybe 3 of his drives fit. I don't know. I can almost guarantee is producing too low of cubic feet a minute, also known as CFM, and actually airflow gland on my cable properly dissipate the heat. What you're about to see, I highly recommend you pay attention to. Many of you can stay tuned because I actually cover the proper way to set up a cyclonic airflow system.
board up to.
Okay guys, you can see we have our cyclonic fan configuration. Once again, dealing with an IDS system I built for a client, which stands for individual drive system for my new guys out there. Once again, you have a fan that is intake, so we can actually blow over our drives and our heatsink, and then our extraction fan here, and you can see the animation. You have an arrow coming here, an arrow going there. If you didn't see it, just replay this portion of the video and you'll see it. This is the correct configuration when you're dealing with drives. Also note that the enclosure I'm using, of course, is designed by myself. It completely breaks down, and not only that, it's the proper size. You need a large enclosure so you have proper air circulation. If you confine your electronics, ambient heat will still come into play, and it will restrict the electronics, possibly causing overheating. So think about this very carefully.
The bottom, then once the cover's on, you'll never even notice it.
Angle grinder to the rescue.
Well, I believe it's safe to say, guys, many of you have never seen anything like this. I know I haven't, and I cannot believe really what I'm seeing. He's got new drives in there. He's got electronics in there in general. He's got an open electronics box on the other side, and he's grinding with an angle grinder to notch this enclosure. Now, we all know the correct way to do this, if you're going to do that, would be to have your electronics naturally uninstalled, and of course no cables present, and of course the enclosure unmounted from his mill. That's just shooting metal sparks, scarf, everything everywhere. And it naturally can melt any of the cables, casings, or cables that are present there. This is extremely dangerous practice to think about when you're going to then power up the system. Guys, please be careful and pay attention to what you're seeing. This is a video online YouTube. I'm not making this up, and it's frightening to think this is actually being seen.
A little more cutting, and then I filed it all smooth. It should work pretty well.
Decided to use electrical tape to insulate the bottom of the breakout board for the DB25. Guys, do not use electrical tape. As the glue weakens, your insulator then becomes loose and will fall off. You properly would pot this with silicone. That's the proper way to do it.
I went ahead and added the 1 amp fuse that the Masso controller asked you to put in from the power line, or from the power source. So actually my power supply is coming through to this rail, and then before it heads up to the controller, I have a fuse in here. I didn't show it, but I've gone ahead and got.
Okay guys, we zoomed in. We can see his DB25 breakout board there, so he can connect everything. And once again, we see shield drains that are cut. Nothing is attached. Just to clarify once again, there are no connections here for ground, and therefore using the proper cable would have eliminated all of that. And of course, Masso should always let their end users know how to properly ground the unit, including the accessories attached to it.
The X, Y, and Z motor wires hooked up to this breakout board. Alright, got all the motors wired up to this. I've been making a chart as I go so I know what it is when I get to the other end. Okay, I've got everything from this DB.
Well guys, now we can see he's basically wrapping up his transition with installing the G3 in its enclosure, and the DB25 he installed. And now I'm going to show you the way a proper ground split is done using one of my clients' IDS systems.
The 5 motors and the spindle, and I guess the power too. So yeah, I somehow way miscalculated how many connections I needed, so I'm going to buy a second DB25 cable and breakout boards to run the rest of the inputs, outputs, yeah, everything else. Alright, I got the 2 new motor drivers wired to the aviation plugs.
Okay guys, he is now ready to, what he thinks, let this system accept power by letting it turn on. I've seen this done in previous videos. A lot of end users like to temporarily wire their system and then turn it on to see if everything works. Well, if you temporarily wire it, do it in a way that is hooked up correctly. Please do not mimic what you're seeing here and just throw it together and then turn it on, because odds are you're going to probably have a problem, especially seeing what he did prior. This is definitely not best practice, so please be careful. And again, take into account how much money and time you've just spent. You've just spent thousands of dollars. Take your time and do it right.
And yeah, everything over here is what I have left to do when I get the other DB25 connector. The plug's right there, so we can test it out and make sure that that's working too. I've got the pendant all wired up. I had to solder up all the wires to this DB15 connector, and it needed 5 volts, so I put in this step-down converter here. And yeah, let's see if it works. Thanks.
Okay guys, this is what we see on so many online YouTube videos, and that is that an end user assembles what he feels is a CNC controller, and then he gets motion by jogging his axis. In his case, he's using the pendant, and he feels then that everything is done. He's all stable, the robot's ready to go, and it's ready to basically produce profit. Let me explain the truth. The truth is, you don't have a production robot until it's demonstrated stable production. It is not fully commissioned until that robot's been calibrated on each axis to show repetitive motion, and then perform the duty you assign it in terms of the G-code you load into it. Right now, all he's proven is that he's actually connected the leads according to the so-called wiring diagrams, and he actually can move each axis. Do not confuse a stable robot with motion. Big difference. And you can relate that to many things, but an animal that has brain damage produces motion. It's probably not going to be controlled. Think of robotics the same way.
Okay. There's the final wiring of everything inside here. It's not too pretty, but it's not too messy.
So guys, tell me what you think. Is it not too pretty and not too messy, or would you build a controller in this fashion? I'm really curious. I'd love to hear your comments below.
See either. So I think I can finally close it up and get to setting it up.
Hey guys, that wraps up part 8 in the series. Once again, I hope you've learned something. I cannot emphasize this enough. This is not a beatdown series, but an education series. And this way you guys are well informed, and the choices you make will be based on using correct knowledge rather than passed on misinformation, which unfortunately is all over the place. I want to thank everybody again for helping the channel grow as rapidly as it has. I certainly appreciate it. Take care.